Hello, we're Group 23. In this video, we will demo our automated rotating solar plant rack with self-care capabilities project. Our group members include Abigail Michael, Brian Guybeck, Cristina Quiñones, and Melissa Rose.
Our team members are Cristina, Abby, and Brian, and myself, and we're all electrical engineering students.
The project goals and objectives include making sure we create a system that will autonomously provide water and sunlight to a plant, create a system that can ensure its plants grow straight up rather than towards the light source, provide a method for caring a plant when one cannot be present, and create an easy-to-use interface that can be learned in a short period of time.
The impact of this project is, if it was widely implemented on a massive scale, is that anyone would be able to take care of plant life despite their busy schedules or lack of experience. We started the project by choosing and ordering components and designing a PCB. Once everything arrived, it was soldered together and the programming began. The code was placed on the PCB and the entire system was tested. In the meantime, the app was designed and the database PHP code was written. By the end of the semester, we had the entire system working.
In order to collaborate, we met every Tuesday and Thursday on Zoom and discussed our project. We made sure to keep a tight schedule that assured everything was finished in 2 semesters. We also kept an overall list of everything that needed to be done, as well as events that would occur. Throughout the planning phase, we all had work and class schedules that we had to work around. Overall, we made enough time for the project and were able to get it done.
We were motivated by our interest in plant care systems, automated technology, and electromechanical design. We received design and implementation feedback from our advisor several times throughout the semester. We would take everything he said and implement it in our project immediately.
During the project, we learned that it is important to always take time management seriously. Time is precious and must be spent wisely. It is very easy to get behind and lose track of what needs to get done. Our motivation for choosing this particular project came from one of our group members. Our group member has a grandmother who is an active gardener. She will struggle with maintaining a busy schedule and taking care of her plants. We want to create a system that will allow her to grow her plants despite her schedule.
The project measures the sunlight and water levels of the area surrounding the plant and uses that to determine whether the plant needs care. If it does, it will either deploy or retract the shading system or turn the water pumps on.
Okay, so in this next section, we're tasked with testing the 3 sensors that are used to input data for our system. The first of these sensors is the temperature sensor. As you can see, the temperature right now is about 74 degrees. However, when I use my body heat on the temperature sensor, we can see it slowly climb. Right now it's already at 77 degrees, and now it's at 78. The next sensor that we're tasked with testing is that of the light sensor. The light sensor, we can see when we adjust the ambient lighting of the area, should go down. Right now I'm turning down my light. We can see the lux went from 339 to 210. If I cover it with my finger, our lux reading goes down significantly to 10 lux, nearly no lux. And if we turn the brightness on maximum of our lighting, we can see a high reading of about 1,800 lux.
In this demo, you can see the operation of the rotational system. Usually, we would set the plant to only rotate once every 30 minutes or so, but in order to demonstrate that it's working properly, we have sped up the interval at which it rotates. This system will ensure that the plant receives an even amount of sunlight on each corner.
Okay, so one of our specifications that we had to demonstrate was the use of the moisture sensor in order to automatically irrigate the plant. So we have our whole system right here. We have our water emitter on very top. And how this works is the moisture sensor acts as a variable resistor. And it basically is measuring the conductivity between the 2 leads. And the way we've written our program is that if the moisture level of the soil falls below a certain level, it will turn on the water pump and pump water into the system. So right here, we have the moisture sensor inside this cup demonstrating a saturation of water or a plant that is well irrigated, so there's no water pump going off. However, if I were to remove the moisture sensor, this would demonstrate a plant that does not have water. And once removed, the water pump pulls regularly and the emitters drip water in until there's an acceptable level.
Thank you so much for listening to our presentation. We are so honored to have you here and hope you enjoyed hearing about our project.